Yet another example for class 10 in dynamics. Here's a problem out of Hibbeler's 12th edition where we have two cars, one with a mass of 2 megagrams, wow, and the other one has 1.5 megagrams, respectively. And we want to determine the magnitudes of their velocities if after they collided they stick together and they move with a common speed of 50 kilometers per hour in the direction shown right there, right? So they're going to hit and they're going to move, right? So we want to figure out and they're going to move, and somehow we're able to measure, and they stick together. Now this is the first one where we have multiple particles, and this is our first collision. In the next class, we're going to introduce something to the coefficient of restitution, which is going to be how bouncy things are. So things don't necessarily stick to each other. We will, in that class, note that that coefficient of restitution, when they do stick together, is equal to 0, right? If they're perfectly bouncy, it's a coefficient of restitution of 1. So it varies between 0 and 1 right here. So what we're witnessing now is a collision with a coefficient of restitution of 0. You just said that. Okay. So anyway, let's move on to this example problem. And so we see the two cars traveling towards each other. So let's draw a little diagram here. We have our initial, we have impulse, and we have final. So the initial thing, we have a car coming up this way, and we have a car coming up this way, and they haven't met yet. So this guy is going to have MA VA1. This is MB VB1. Now we're going to have our impact right here, and I like to draw a little explosion. And if we were to put in these impulses, they would look like this right here. And they'd be equal and opposite, and therefore they would cancel each other out. Okay, they should look equal and opposite. They should be in the same direction in order to be equal and opposite, right? So they're going to equal to, and now I kind of like show them superimposed with each other. Now they're going to have this velocity, which we call V2. So let me actually, this is a momentum diagram, so we'll not draw the velocity on here. It's going to have MA plus MB times V2. I guess I can give him a hat because he is vector. And so here is our x's and our y's. So in the y direction, we're actually, we can go to the x direction and the y direction, but in the y direction we're going to kind of get lucky because we can just have, the only thing that we're going to have is this guy, right? And he's going to be at 45 degrees right here. And I guess the angle, this one was 30 degrees, so I guess he goes 60 degrees is the angle. It's right in there, right? And so anyway, so let's go to the y direction of this. Actually, above it, I say the summation of the masses times velocity 1 plus the integral right here is equal to summation of the masses, not the summation of the masses, but the summation of the momentums. Right here. So that's basic. This is the equation. Now we're going to break it down into the y direction here. And so we're going to have MA, I guess I decided to write this out, MA VA1 times the sine of 45 plus, this cancels out here, and it's going to be MA plus MB, and that's going to be times V2 times the cosine of 30 degrees. I guess I decided that I wanted to go with the cosine of this angle right up in there, because that's what they provided. So 2000 times VA1 sine of 45 plus 0, and now we're going to have the 2,000 plus the 1,500, and here's our 50 cosine of 30. So VA1 is 107.2 kilometers per hour. Now if we go into the x direction of this thing, we'll get MAVA1 times the cosine of 45, and then minus, because the other guy is traveling in the negative x direction right there, so you got to be careful, make sure we get these signs right. And the entirety of his velocity is in the horizontal direction, and then there's no impulse, so I put it out there as a space holder. And then we have our oh no, I can use that, MA plus MB times V2 sine of that 30 degrees, and then plug the numbers in. 2,000, we found this guy over here, 107.2 cosine of 45 minus our 1,500. Here's what we're looking to find, and we have our 2,000 plus our 1,500 times 50 that we knew somehow. Maybe somebody had a radar gun right there at the intersection, was wanted to find them. So we have VB1 was going at a meekly 42.74 kilometers per hour. So this guy was probably doing the speed limit. This guy's probably a reckless driver right there. So we could find them, and yeah, so they asked for the magnitudes, so we're okay. And yeah, so the end of the that's the end of the example right here. And I had extra examples. Maybe I'll just post the video, the pictures of them. So that's it for today. Thank you.